Here's our second example looking at confidence intervals for the difference in proportions. We are looking at randomly selected teens, age 15 through 17, and it looks like 57% of the 248 boys had posted online profiles compared to 70% of the 256 girls. We're going to calculate the 95% confidence interval for the difference in population proportions over here. And this time we're actually given our sample proportion. So we have the proportion for the boys. Our sample proportion is 0.57. We have our sample proportion for the girls, which is 0.7. And remember, when we're calculating this in StatCrunch, we actually need to know the number of successes for each group. So 57% of 248 is equal to 141.36, which, really that's 141 boys. And then for the girl group, we have 70% of 256 girls. That's 179.2, which is 179 people. All right, we are going to enter this into StatCrunch and calculate the 95% confidence interval for the difference in population proportions. Going to the proportion stats, we're looking at ToSample with summary over here. We have 141 out of 248. We have 179 out of 256, and we are finding a 95% confidence interval. Over here, our lower limit is negative 0.21 to negative 0.05. So over here, all negative values, which means it does indicate that there's a difference in these population proportions. So lower value of negative 0.21, upper value of negative 0.05. We are 95% confident that the true difference in population proportions, and we're looking specifically for boys minus girls, is between negative 0.21 and negative 0.05. Since 0 is not included in our interval, it is not possible, or it's unlikely that the proportions are the same. So since 0 is not included, we have convincing evidence that the proportion is not the same for boys and girls. And one last quick example over here, looking at tax spending, looking at two different voting districts, District C and M, where C had 22% responded yes, looking at increase in state spending for the arts, and District M, we had 26% responded yes. We also got a 95% confidence interval looking at District C minus District M. We had this confidence interval which started, or is, negative 0.04 plus or minus 0.12, and trying to find the correct interpretation of that. So subtracting these two values, negative 0.04 minus 0.12, gives us negative 0.16 as the lower limit, and then adding negative 0.04 plus 0.2 gives us an upper value of 0.08. So let's look at each one of these outcomes over here. It says we're 95% confident that the majority of all voters in the states favor an increase in state spending for the arts. Well, it's actually 22% and 26%, so that is not true. We're 95% confident that the majority of all voters in the state favor an increase in start spending. Again, I think that's the exact same statement over here. C, we're 95% confident that less than half of all voters in the state favor an increase in state spending for the arts. Okay, that looks pretty good. We're 95% confident that less than half of all voters in the state favor an increase in state spending for the arts. And then the last one is we are 95% confident that the difference in proportion of all voters in districts C and M who favor an increase in state spending is between negative 0.16 and 0.08. Really what we're looking for is the difference in proportion between these two districts. We're not really looking at, the entire state, and therefore C and D is a little more than we can say because we don't have that information.